Same idea though, exact same path here. So I'll, page 33. 33. Okay. So supplementary, you should think 180. There's a couple of things that are going to happen here. I'm just going to throw it at you. First of all, you have the fact, let's start with the fact that a ship travels south. So this is south right here. Right? So you leave the port and you're going straight south. All right? So straight line, that's important there. And you go for 2 hours at 35 kilometers per hour. I did mention this at some point at the very beginning, what we do with that. Okay? It then changes course and travels 20 degrees west of south. That sounds kind of weird, doesn't it? West of south, but it's what's happening is if you are the captain of the ship, you're traveling and you're like, hey, I have to turn 20 degrees. So make an arrow, a little arrow head, introduce that, just saying that ship turned 20 degrees to the left in this case, or if you're actually on the ship, you'd be turning to the right 20 degrees. That's all it's saying. So just go by the diagram if that throws you off. And you're staying on that new path for 3 hours at the same speed. Right? So I'm going to use two different colors here. 2 hours at 35 kilometers per hour, that'd be this. And we traveled 3 hours at the same speed going this way. So the boat is ultimately here. This is the actual traveled path, okay? And the question is asking how far is it from the port after 5 hours? Why does it say 5 hours, guys? 2 hours and then 3 hours, right? A total trip time of 5 hours. It makes sense, adds up. So I don't know if you remember, but distance is hours times the speed. Okay? If you ever want to find out the distance you traveled, I don't think this is a stretch for you, right? But we'll go 2 hours at a speed of 35 kilometers per hour. That gives you, what's 2 times 35? Mental math here. 70 kilometers. Okay, that's the green stretch. Let's put that over here, 70 kilometers. That was the first 2-hour trip. So we're developing distances, in our case, side lengths of the triangle slowly, right? And then 3 hours, this could have been 3.5, it doesn't matter, right? So the 3-hour trip at the same speed, it could have changed the speed, but it didn't, right? 3 times 35, mental math, 105 kilometers. Right, 105 goes here. So now we turned our time and speed into actual distances. We can now transfer that over here, right? That's where we got that from. So we have to do a little bit of work on the side there. And angle is outside the triangle, right? You see that? You will have one at least on the test or quiz like this, where it's on the outside, but it has to go inside. Okay? Those calculators are like a ton of bricks. It'll be fine. I have those too. Okay, so let's zoom this out, right? We will say this is what's happening here, right? If you just focus on this line, there's a straight line, and then you're cutting it like this. Would you agree with that? So this angle here is 20. Let's do some mental math there. If this is 20, what do you need to complete to 180? 160. That's right. So that 160 is what's going to go in here. So if you have another color, I want to focus on this one here, this one right there. That's there. Some of you are like, I don't do highlighters. That's okay. So the 160 goes in there. Okay, supplementary. Don't worry about the word, but it means that adds up to 180, right? So now we have our angle inside and we're good to go. What law will I use to figure out, because this is what they want, right? What law will I use for that one? Side, angle, side, cosine law. Or I'm going to try to look for a pair. Don't have a pair there, don't have a pair. I just don't have a side angle pair. I have to use cosine law, right? So this is side angle side, cosine law. And you will use, in this particular case, right, you go to SAS on your study sheet, you should have the formula for an SAS, because cosine law you have to pick SAS or SSS, right? And so it's this case, so we go x squared is equal to, we take 105 squared, 70 squared, no decimals in this case, minus 2 times 105 times 70 times cosine, not of 20, right? 20 is not even, it just helped us, but we will not use it in anything else. Does that make sense what I just did there, guys? I hope this is the only new thing that I'm introducing here, that you have to be able to bring stuff inside the triangle. Okay, so let's figure this out. Do you remember how to do this? I'll give you a few seconds to figure this out. See if you remember what needs to be done to solve this, because we're almost there. It should definitely be more than 105 and more than 70, right? Because it's an obtuse angle there. Let's see what you get. How would you even show your work? So this is what you got. Is this right? It's technically not right. There's something wrong with that. I dropped that square, right? If you want to drop that, you need to take the square root of this. You're basically taking the square root of both sides. That's really what's happening. You wanna have the fancy version of this step? This is what it is, guys. You're technically taking the root of both sides, and that cancels out. The root cancels out with the x squared, with the exponent 2. Okay? And so x is 172.45. Just imagine like 29,000 kilometers, right? You have 105, it doesn't make sense, right? So maybe just look at the question and see if it adds up. Okay, this is a fairly straightforward example, right? I'll tell you what's coming your way, why I did this, right? Other examples, right? Other cases. Classic one. You're not going to solve this one. I'm just making this up, so it might not even be solvable. But let's say you have the ground here. There's a there's a tower here, and somebody's standing here looking at the top of that tower. Somebody else is standing a little bit closer, also looking up to the top, right? You ready for this? So the question might give you this angle. Let's say it's 50 degrees. This person is looking up and it's 50 degrees. But you have a lot more information in this triangle back here, this one here. What should you recognize here? You should recognize, oh, there's a straight line there, right? If this is 50, then what's the other part of it? 130. Yeah, you're saying it. That's good. And voila, you now have an angle in here. Okay, and so you need to know, oh, I have this angle, but I also have this one, right? You're given two angles in one step. Right? So watch out for that. Watch out for that. Okay. So supplementary, think of the hat. Can you make a hat at that point, right? So I want you to try at least one page before you go today. So go to page 34 with me. We are getting closer to the end of new stuff, and then I'm just going to throw a mix at you to practice all of them at different stages, right? So go to page 34, look at this one here. And it may look a little scary, but just answer what it's asking you to do, right? I think I just want to let you struggle with this one for a bit. I was gonna like introduce it and, hey, do you remember three-letter notation? Where would that be? But you need to struggle right now, and if I walk by and you need me to tell you, I will help you. But everybody else, you just give this a try. So page 34, 35, and 36, they're all complementary / supplementary examples, all right? So give that a try. And I can post the key to that as well. There are the answers to the first page there. If the three-letter notation bugs you, you can gladly assign it a letter. So just go right under it and just say, hey, I'm going to call that angle X. So EFD is right here. Just put the X there, right? And now you don't have to worry about constantly using the three-letter notation, right? But angle X is simply 180 minus 70, which is 110. Angle D is 180 minus 40 minus 110. Is it?
Yeah.
How so?
Well, I called D and FD, I got that number. And that's time,
Oh.
It's higher than the bottom one.
So ED is this one, right? Which is longer. It should be longer than DF.
Yeah, I called that F. But yeah, when I called it E, crossing D, I called.
Okay.
Yeah, it's a weird number because the bottom one's higher than D.
This one?
Yeah, I guess it's D. Yeah, D is higher than D.
Because
D is higher than D, sorry.
This one is longer than this. Yeah, it's not drawn to scale. My bad. I tried to like make the obvious ones longer, but sometimes I'm guilty. Oh, okay. Just focus more on the angles across the sides you're finding, and then you're safe. I can give you the answers to the other question there. If you want to go to 35, that would be 130 degrees. This would be 4.19 miles if you figure out the angle of elevation between the ground and Natasha's line of sight. Sorry, the angle of elevation between. Okay. I don't think I calculated that yet. But the height of, for D, the height is 1.42. 1.42 miles. Anybody figure out C already? What is it? 1988? Yeah, no, not sure. Anybody else? Rika, did you get there? Oh. I will check. What about? Okay. So I'll tell you this. I'll post the key all the way to 36. I think 36 is a complementary example, right? Yeah, there it is. So it's kind of like that first one we did yesterday.